In this video, we are going to go over how to create a MONSUM 1 entry for MSC Natsran. So this entry is going to combine multiple monitor points together. And then here in this other window, this is what I have for today's agenda. Number one, I'm going to show you how to create one of these MONSUM 1 entries. I'm going to help you interpret the results. We're going to go ahead and output the results to the CSV file. I know many of you are, the habit is to read the F06 file. I'm going to show you a much easier way to output this data to CSV file. Here, for today's exercise, this won't be necessary. And then I'll show you how to quickly create multiple versions of this MONSUM 1 entry. Okay, so let's go ahead and get started. In this window, I have the Natsran model we're working with. And one other thing, everything we're doing here is going to be done in a web browser. So just in case you want to follow along, if you want access to this web application, you can visit theengineeringlab.com. Here in the top right hand corner, you click on the blue button for a free trial, fill out the form, submit it, and we'll go ahead and give you access to the web app. Now, here, I'm assuming you've already watched the other videos on how to create monitor points. This is going to be a continuation of those previous videos. Now, in the previous videos, one thing we were focused on was determining the deflection at the free end of the beam. So in one of the earlier videos, what we did, we created these MonDSP1 entries. Let me actually show you what those entries look like now. We created these MonDSP1 entries, so that would be these two entries here. These MonDSP1 entries were used to track the deflection on the free end of the beams. So from this fringe plot, we know that the deflection is, well, let me show you the actual deflection with the value, with the sign rather. Oh, what am I looking at? Oh, I'm looking at the maximum values. Should be looking at the minimum values, right? So for the free end of the beam, the deflection is about negative 0.0013 meters. So keep that in mind. That's going to be a very important number during this entire exercise. So negative 1.3 negative 3 meters. So keep that in mind, is the tip deflection. Now what we're going to do is the following. We are going to use the MONSUM 1 entry to combine these monitor points together. There are two formats. There is, I'll call it the primary format, and then there's the alternative or secondary format. First I'll demonstrate the first format, and then I'll demonstrate the second format. Okay, so let's go ahead and start creating a MONSUM entry. So for this, we'll go to the pre, go to bulk, and look for MONSUM. We'll open that and create one entry for now. And we'll give it a name. Right now, if you try and use an integer for the name, you'll get an error. So we'll call this a psum 101. And then for the label, we'll call this test summation monitor point. So here we're just going to experiment with summing these monitor points. Again, these are tracking the tip deflection, and the value at the tip is negative 1.3 meter or 0.00129 meters. Okay, let's go back to the pre. Let's click on add row. So group 1 here at the top, this is going to correspond to this first format that you see here. Now in that table, you're going to be following this format here. So for new axes, let's go ahead and populate that now. We want to say we want to report, I forget what this does, but I believe it's going to report values for the 6 components. And then here for the axis 1, which values from the the monitor point are going to contribute to the summation. So here for now, I'll say, you know what, take all the deflections along the 3 degrees of freedom of translation, take all the rotations, include those in the summation. Here for M type, I'm going to say SMON DSP1. So this stands for Structural Monitor Point MON DSP1. The A stands for Aeroelastic or Aerodynamic Monitor Point. But here, since this is a SOL 101 or a linear statics analysis, we'll go ahead and use SMON DSP1. And then here we'll go ahead and select the monitor point for the tip of the beam, which again has a deflection of negative 1.3 times 10 to negative 3. And then for the coefficient, we'll use 1. Let's go ahead and run this quickly. I forgot what the name of this monitor point was. MSC 101. Okay, so you know, one thing I want to disable. This by default will jump to the French plot. I want to disable that. So we'll go ahead and turn off HDF5 out. If there's no HDF5 out, there's no H5 file, so you cannot display the French plot. Let's go to run. Let's look at the F06 file because that's where we have the monitor point. So this is the first monitor point we created. And now let's do this. Let's confirm the deflection in the y-axis is negative 1.3, and you can see it is in fact negative 1.3. Okay, now again, this is being done, I believe, let me see if I have a, okay, so I do. MONSUM, where's the label at? PSUM, let me think about this. Oh, right, they wouldn't be here, right, okay. So this entry doesn't specify a position. All this entry does, it just sums the monitor points together. There's no position or orientation involved. For MONSUM 1 and MONSUM T, they do consider, or they perform the calculation at a specific point and orientation. So here for MONSUM, there is no position, there's no orientation, so there's nothing to display in the viewer, if you will. So let's do this. We know that this is the output of that monitor point. Let me disable the other components. Let's see if this will work. We'll go back to that MONSUM entry. We'll say, you know what? Only consider the deflection along the y-axis component 2 in the calculation. So we'll go ahead and rerun this. And then we'll go to result files, and then here we'll copy the new monitor point. So this is in the F06 file. And you'll notice that now with the new monitor point, since we did not include the components 1, 3, 4, 5, and 6, the values are 0 for those components, as you see here. Now, I believe, let's see if this will work. A lot of this I haven't scripted. It's kind of experimental. Let's suppose we only considered new axes equal to 2. What I expect to happen is something like this. So we'll see if we get that. So we'll go back here. It's done running. We'll look for that monitor point. I forgot the name of the monitor point. Okay, perfect. So that our expectation was realized. So now we only have CY being reported. So that's how you modify the new axis and the axis 1. Okay, now let's look at the output here. So let's suppose you want to add an additional monitor point. You will scroll to the right. So right now we populated columns name 1, axis 1, and coefficient 1. If you want to add an additional monitor point, you can use these next columns, name 2, axis 2, and a coefficient 2. So here we'll go ahead and select MON DSP 106. Let's select all the 3 components, and we'll type in 1. So that's one way of doing it. I'm not a big fan of putting multiple values on the same row or multiple monitor points in the same row. So this is what I'm going to do. I'm going to remove all that. I'm going to create a second row. And then here, this is where I'm going to configure the next monitor point to add. And then I'll do this maybe 2 more times. So we'll go ahead and do this. So here what I'm doing is I'm taking the same monitor point and I am adding it again and again. I'm adding it 4 times. So here you would type in 1 for each coefficient value, or you can use this row here. So here I'll set everything to blank, so not every row in that column is blank, or you can type in 1 and not every row is 1 in that column. So now let's rerun this. What do we expect here? So we took that monitor point and we added it 4 times. So let's go ahead and multiply that by 4. I should get a new total value in the monitor point of about negative 5.2 times 10 to negative 3. So let's go ahead and confirm that. We'll go to that monitor point, which is this monitor point. So PSUM 101. And let's go ahead and delete all these other ones. So here, remember, this was the original monitor point. When we added the first when we took this monitor point, let's go ahead and display it. I think it was 106. Right, so we took this monitor point and we added it 1 time, and we got a deflection value of negative 1.3 times 10 to negative 3. Then in this latest run, we added that monitor point 4 times, and we did the math. The total sum should be about negative 5.2 times 10 to negative 3. I went to the F06 file, copied the new monitor point data, and then if we look at the Y value, it's now negative 5.2 times 10 to negative 3. So that is the first way of defining the MONSUM entry, or MONSUM entry. As you saw, it's very simple. It's just you're just adding the components from all the monitor points together. If you had monitor points from some other source, like let's suppose that we had, I don't know if you would do this, but if you had a monitor points from aerodynamics, so a so-called AMON DSP1, you would say AMON DSP1 there, and then you would select the monitor point 1, you would select the components that you want to add, and then the scale factor if you wanted to scale something. So here we're going to actually double the values from this monitor point. So that's something, this is what it would look like if you were going down that path. Now keep in mind, you could still modify some of these other columns, like 1, 2, 3, 4, and 5, and 6, but be careful. That may cause an error. So here you can see that the format that we see here in the documentation looks a lot like the format we're following here in the web app. So make sure you're following the format that's in the documentation. Okay, now we went over the first format. Let's go over the second format. So this format is a little different, but if you configure it in a specific way, you'll get the same values. So here, let me walk you through that process. What I'll do here is this. We'll leave this monitor point as is. So again, we're just summing up the same monitor point 4 times. I'll create a new monitor point, and I'll use the second format, the so-called alternative format. So the alternate format, this is defined in this other table called group 2. So in this column, group 2, click row. This is where you can configure the alternative format in this group 2 column. So we'll say consider the MON DSP ones from the statics analysis. We want to output, or we want the monitor point to have 6 components. We'll consider monitor point 106, and we'll take the 6 components of this monitor point and we'll include those in the calculation. Here I can I can repeat this 6 or 4 times and get the same value, or I can just type in 4 there. So multiply the components by 4, and both of these configurations should mean the same thing. Here I'll use 2, and then I'll add another row, and then I'll use the same MonDSP1, same 6 components, and 2 here. So here the total is 4 here in this alternative format. So let's go ahead and rerun this. Let's make sure that the name is updated. So if you want to scroll horizontally, you could do this with the shift key. Hold the shift key and move the scroll wheel, and you can move pretty quickly. I'll call this PSUM 102. And let's go ahead and rerun Natsran now. And let's do this. Let's go ahead and delete. Let me delete. I'll keep this, which was the very original summation. And then here I'll copy over the new summation. So remember that we are now multiplying those components by 4. So for this first monitor point, for the first summation, we get negative 5.2. For the second monitor point that used the alternative format, so this format, that would be this next monitor point, PSUM 102. You can see it here in the point name. And you can see the value is also negative 5.2. So like I was saying before, both of these formats, if configured in the right way, will yield the same values. But I guess these formats are here because different groups prefer different formats for the entries. So you have different ways of defining your summation. Okay, let's go ahead and look here. Let me make sure we're... Okay, so I created the monitor point. We interpreted the results. Okay, so how do we output these results? Let me turn on HDF5 out. So if you've been watching the other videos I've created, I recommend to avoid reading the F06 file. I think I just purged it, right? All right, let me download a copy of the F06 file. I discourage as much as possible reading the F06 file. It's not a fun task. It's full of a lot of issues. It's my opinion that this file was never meant to be read with the script. You'll find that these columns, these labels, all of this data is not consistent. This makes it really difficult to read the F06 file. So that's why I encourage everyone to avoid reading the F06 file. So, but then the question is, how do I output this data? Our preferred way is you open the H5 file, you extract the data from the H5 file. You can actually do this. I didn't mention this in the other videos, but there's actually a program. There's actually a program for free that will let you extract the data. So here's an example of what the program looks like. Here in this window is a table. You can actually use this program to open the H5 file and get the monitor point values if you want. This is a lot easier than reading the F06 file. Another free tool is the HDF5 Explorer. So here, let's go ahead and look at, I forget what this was. I don't even know. I can't remember if this is even output. PSUM 101. Let's look in the MonDSP1 entry. Okay, so it is here. Right, so for a moment there, I forgot where this data is available. So in the HDF5 Explorer, this is going to be this MONSUM data, this MONSUM data, monitor point. This is going to be the MonDSP1 data point. The reason it's in the MonDSP1 entry is because, let's go ahead and look at this. Here in the group 1 and group 2 tables, am I in the right place? I'm on some. Here we're using MonDSP1, and a lot of the values here are MonDSP1. I suspect that if you use MonPNT1 as an example, it will put the data in the MonPNT1 data set, but today we only use MonDSP1, so this is where the data is available. Here, you can do a few things. You can create a plot if you wanted to. Where am I at? So here we'll look at the Y component. For the name, we'll switch this to a bar chart. And then here we'll only consider MONSUM 101 and MONSUM 102. So you'll notice that we get a negative 5.2 times 10 to negative 3. If you like this bar chart, you could download a CSV file here, and it will contain all the data that was used to create this bar chart. But if you prefer this table, this has all the monitor points, including the ones for the MONSUM entry, the values for, so the CX, CY, CZ, and so on and so on. Those values are now in these columns. And what's really nice about this approach, if you had 100 subcases, you have one row for each subcase. And you can imagine that if you had to read the F06 file and you had 1,000 subcases, that's going to be very difficult. But here, no problem. Actually, let me see if I can show you that. MonPNT1, MonDSP1. Let's actually try that. Let me make sure this runs actually. Let me add 2 additional subcases. Okay, so, all right, so let's do that right now. Let's add 2 additional subcases. Subcase 1 and 2. Let's go ahead and output. Let's go ahead and assign our loads and boundary conditions. So we'll do that here and here. And then our loads also. So what I'm doing right now is I'm assigning, I created 2 additional load cases. So you can imagine the volume of data in the F06 file. It's going to be a lot more than before. We have to now read more data from the F06 file. This is more pain. This is more difficulty. Let me actually download the F06 file and show you. So here on my desktop, so here I have the new F06 file. You can tell that the file size is actually larger than before. Before we only consider 1 load case, but now we're considering 3 load cases. So we open this F06 file. You can see we have even more data for the MONSUM entry. Subcase 1, subcase 2. This is more data you have to read and parse, more time you have to take to write up your scripts. But here, what we're going to do is we're just going to open the HDF5 Explorer. We're going to let this tool extract the data for us. We're going to output it to a CSV file. So we'll go to MonDSP1. So you can see there are even more rows than before. Let's go ahead and download the data to a CSV file. And we'll go ahead and open this in Excel. And then for, if we wanted to, let's see if I can filter this. Filter, and then we'll go ahead and look for only MONSUM 1. And then if we look at component Y, which was, oh, this one, sorry. So this was the deflection added 4 times. So it's negative 5.2 times 10 to negative 3. Here, the values are all the same because all 3 load cases, I use the same loads and boundary conditions. But here, I wanted to prove to you that if you have 1 subcase, 10 subcase, 1,000 subcases, you don't have to spend a lot of time digging in the F06 file. No, there are tools available for you. Here, the HDF5 Explorer is free. You could go ahead and just use this tool to extract your data. And now you can go ahead and do additional calculations if you wanted to. Okay, I think we're pretty much at the end of this one. Oh, one last thing. Suppose you wanted to create, or suppose you wanted to go faster with the setup. You can actually move, or rather, you can actually download a CSV file for this sub table. So let's download it. Let me delete this. I think it's in the far right hand corner, right? So here you see these two buttons. If you click on this button, it would download a CSV file of that table. And now you can use Excel to go ahead and do the summation for you. Or you can use Excel to add more monitor points to that summation. So here, let me go ahead and do this. Let me see how many times it's here. We'll do it maybe 10 times. So here we'll just go ahead and we'll do the same, but this time we'll use a coefficient of 1. So here what I'm saying is take that one monitor point and add it 10 times. And let's go ahead and make sure the coefficient is, or here, you know what? I'll leave the coefficient as 1 through 10 for now. We'll fix that here in the web app in a moment. So we'll go ahead and upload this group. And now I have 10 summations here for the same monitor point repeated 10 times. But here for the coefficient, I have to adjust that. I want all the coefficients to have 1, so we'll make that manipulation. And let's go ahead and run this now. So it's very important that we move quickly with all of this. So that's why I'm showing you that we can do this with CSV. Now, what do I expect here? Since we're adding that monitor point 10 times, this value will become this value. So let's confirm that. So we ran Natsran. Let's go ahead and dig in the F06 file. PSUM, I forget what it was. Was it this one? Oh, I got my bearings mixed up. Oh, right. So one tricky thing about this window, this only shows you 1,000 lines. So if you want to see the full file, you would go here, click on download, and then look at the local copy of your F06 file. Let's look at this monitor point now. Okay, let me look here. Negative 5.2. Oh no, I should be looking at 102, sorry. Okay, perfect. So let's go ahead and move this here. So at the very beginning, we only did a summation for one monitor point, and the deflection was negative 1.3 times 10 to the negative 3. And this new summation, we added that monitor point 10 times. So you see here, let me write it down here. Negative 0.0031 or 13, sorry. And now we're getting a different value, negative 0.013. So notice the exponent changed, and that's because we added that monitor point 10 times. Here, what I wanted to show you is that if you wanted to, you could use Excel to do this configuration faster, upload it to the web app, run Natsran. Once you run Natsran, you can go ahead and open the HDF5 Explorer and then click on download. And then you have all the monitor point values in your Excel file. Okay, I think that was one of the last things I wanted to show you. Right. Okay, so last thing, just in case you have a question or comment, feel free to reach out to me at the email address, and I'll get back to you as soon as possible. And as always, thank you for watching.